Hello students, my name is Amisha and I'll be discussing chemistry solutions of NEET 2025 on the behalf of Ellen Overseas. Right? So let's begin. Students, this first question, it is based on Rydberg's formula. It is from the chapter Structure of Atom, right? So how do we start? We have to find ratio of wavelengths. What's formula of wavelength? It's 1 by lambda RZ square 1 by n1 square minus 1 by n2 square, where n1 is the state from which electron is transitioning, correct? So here when it moves from 2 to 3, this is your n1, this becomes what? N2. Likewise in this is your n1 and this becomes n2, correct? So putting values in this formula, 1 by lambda when it moves from 2 to 3 is going to be R. What is R? Rydberg's constant. Since the discussion is for hydrogen, Z will be what? 1. Correct? So I'm keeping Z only because both are same. In first, I will have what? 2 square minus 1 by 3 square. In next, when I apply 1 by lambda would be 4 to 6 RZ square 1 by 4 square minus 1 by 6 square. Students, I need ratio of this to this. So what I am preferring is, let's divide this equation 2 by 1. So students, when we divide 2 by 1, what we get? Lambda 2 by 3 by lambda 4 by 6 is going to be, just see. Students, when I take ratio, RZ square cancel, right? What I'm left with, I'm putting here, see. 6 square, that is 36 minus 16 by 16 into 36. This value would be what? 9 minus 4 into 9 into 4. Simple calculation. When you'll solve this, your answer would be 1 by 4. Option 4. Correct? Fine. Next. This is a theoretical question, students. It is mixed. It's from inorganic. So first is, unlike Ga, which has high melting point, this statement is wrong because Ga has very low melting point. It melts even when you keep it on your palm. First statement is wrong, right? Next, on Pauling scale, electronegativity of N and Cl not same, wrong. Almost same. If N has electronegativity 3, Cl also around 3. It's as per NCRT, right? So it's wrong. Next, they are all isoelectronic, correct? Argon, atomic number 18, potassium 19, but plus 1 means 1 electron lost. Cl 17, minus 1 means 1 gained. So all have same number of electrons. So this statement is apt, right? Next, correct order of first IE. This is exception. You must have all studied that group 2 elements have more IE, first IE, than group 13 elements because of fully filled NS2 configuration. So this is wrong. Why? Because Mg should have value more than Al. So it's wrong. Next, students, atomic radius of CS is greater. This is right. We know as we descend down the group, size increases. So correct option is what? Option C and E. C and E only. That's option 2, right? Next, okay, it's from inorganic analysis of cation anion, right? Simple direct question. I think we all know Mg is present in what group? 6, last group, right? Al is present in what? Group 3. Fe plus 3, Al plus 3, Cr plus 3, group 3, right? Pb plus 2 is in group 1. Next, cobalt. It's present in group 4. So match the following. A3. A3, okay, is 3. B, A4. It should be, just a second. No, A3, B is 4. A3, B4, okay. C is 1, C is 1. D2, option 2. Correct? Next, okay, this is from organic. This, students, we are adding HBr. HBr in presence of peroxide gives what? Anti-Marconic of addition. So first, when I add HBr in presence of peroxide, what we get, students? We get anti-Marconic of addition of Br. Br here. Then we are putting KCN. This we studied in haloalkanes, haloarenes. KCN will cause what? Substitution. So students, instead of Br, Cn would be substituted. Next, what is this? This is reducing agent. Yes, so what it will be doing? It will be reducing cyanide. So upon reduction, what is our product? It gives you CH2, NH2, and this is methyl group. Correct? So option is 1. Fine, let's proceed. Okay, this is again from atomic direct formula. What are the direct formula? Energy is E naught Z square by N square. Radius is, students, R naught N square by Z. Only thing to be done is we have to substitute values. They have mentioned first orbit. First orbit means N becomes 1 for both. Only thing varying is Z. Yes, Z for helium is 2, Z for lithium is, students, 3. Let's substitute value. When I find energy for helium plus, it would be E naught. This E naught will consider this. What is this, students? I think you know. E naught is the energy of electron in first orbit of hydrogen atom. Instead of E naught, they have just written the word RH. Right? We can go with this Rydberg's constant. So I'll substitute this. What is it? 2.18 into 10 raised to power minus 18. E naught is negative. RH they have given positive. I think we know also energy is negative. Like first minus 13.6 eV, next minus 3.4 eV, it's negative. Correct? So negative. Z for helium is what, students? 2. So it's 2 square, which is 4. Let's solve this. 8 4s are 32, 4 1s are 4, plus 3 7, 4 2s are 8. So it's minus 8.72, 10 raised to power minus 18. Do we have option like this? Yes, we do. We have here. Where else? We have, okay, here also. Next, if I find, students, for lithium plus 2, it would be what? Minus 2.18, 10 raised to power minus 18 into Z is what now? 3 into 9. Solve this. 72, 9 ones are 9, 16, it's 9 twos are 18, 9 is 72, 9 ones are 9, plus 7 is 16, 1 carried 18, minus 19.62, 10 raised to power minus 18 joule. See, here we have 10 raised to power minus 16. It's wrong. So correct option is this. Anywhere else you have this? No. So even without solving radius, I can take this option. But if you want, you can solve by substituting values in this formula. Correct? Next, paramagnetic. Students, this is from chapter coordination, right? Paramagnetic means it should have unpaired electrons. So let's check. Students, here, Ni is present in plus 2 state. In plus 2 state, configuration is 3D8 4S0. This Cl is what? Weak field ligand. Weak field ligand means no pairing. How will this exist? Like this. 1, 2, 3, 4, 5, 6, 7, 8. Unpaired electrons means it is para, which is asked. Next, students, NiCO4. Here, Ni is present in 0 state. What is configuration? It's 3D8 4S2. But since your CO is strong field ligand, it will bring 2 electrons from 4S into 3D. So in presence of CO, it exists as what? 3D10. 3D10 means no unpaired electron. So this is not paramagnetic, it's diamagnetic. Next, here also Ni is present in plus 2. But the thing is, Cn here is, students, strong field ligand. It can cause pairing. So here Ni plus 2 will exist as 3d8 4s0, but there will be pairing of electrons. All paired because its coordination number is 4. It can show dsp2, right? So pairing is occurring. It's what? Diamagnetic. Next, students, Ni in plus 2 state. What is configuration? We have already written. Here also H2O is what? Weak field ligand. No pairing. Means configuration would be like this only. So this is also what? Paramagnetic. Last, PPH3, triphenyl phosphine. It's also, students, strong field ligand. Ni is present in 0 state. Correct. Similar to this B. It's 3D10. So it is what? Diamagnetic. Correct option is A and D only. Option 3. Fine. Next, again theoretical question from inorganic. Like nitrogen, ammonia. Okay, ammonia, nitrogen forms ammonia, which is NH3. Arsenic can also form arsine, which is ASH3. Correct. NH3, PS3, PH3, ASH3 all exist. Next, antimony cannot form Sb2O5. This is wrong, students. Due to inert pair effect, Bi2O5, which is last element of group 15, does not exist. But Sb2O5 exists. This exists. So this statement is wrong. Correct. First statement is right. 1 is correct, 2 is incorrect. It's option 3. Fine. Okay. Next is which configurations hail from main group elements. Students, main group elements means S block and P block. So this is from chapter periodic properties, classification of elements, right? Main group elements means you have to check which belong from S or P block. First, obviously, it's group 1. This, don't get confused. No, it's your D block element. D is configuration of copper. Don't see just 4s1 and tick. It's a D block element. Next, this is of P block. It's of group 17. If you check this, it's a lanthanoid configuration, not our main group element. So option A and C only. Option 2. Next, theoretical question, students. We study Dalton's law even in grade 9th, right? So Dalton's law will not state anything regarding what? Gas, law of gaseous volumes. Rest all, yes, directly or indirectly are covered. Direct question. Next, again, very easy question from chapter redox. What is this, students? Superoxide. O2 exists as -1. K exists as +1. K as +1. This is what? Peroxide. In peroxide, we have O2 -2 charge. So one O has -1 charge. This is simple. You can find S will have what state? +6. So option 1. Okay, this is from kinetics. We do in class also direct formula. What is direct formula? Time for 99.5% decomposition is equal to 10 times T half. T half means time for 50% decomposition. So students, in question, they have given T half as 1 minute. Direct question. T half is 1 minute. 1 into 10 is what? 10. Answer is 10 minutes. Over. Next, it's again students from chapter coordination compounds. What is it? We have to give order of wavelength. Students, it is from crystal field theory. You know what? Energy is inversely proportional to wavelength. Correct? So if I find out order of CFSC, order of wavelength would be reverse. Correct? See now. Option C is tetrahedral compound. You know, delta T is 4/9 delta O. So its CFSC is going to be least. Right? Now see. Rest three options. In A and B, we have same cobalt. I think we know that with CO plus 3, NH3 behaves as weak field ligand. Rest all behave as strong field ligands. Even this CN is strong field ligand by default, right? Strong field ligands cause more splitting as weak field ligands. So this is sure. CFSC in B would be more than A, correct? Let's include Ti plus 3 in discussion. Students, Ti plus 3 has configuration 3D1, only one electron. Plus H2O is a weak ligand, very less splitting. So splitting in D is even lesser than these two. I mean, even less than A. Then it is what? A, then B, because B has strong field ligand. If this is order of CFSC or energy, order of lambda would be what? Reverse. It is what? C, D, A, B. Where is it? C maximum, D, A, B. Option 2. Correct. Next, cis-trans isomers. Students, cis-trans exists in alkenes which have similar groups on both carbons, or they exist in ring form also. Let's start. Pentene is this. Will this exist? No. Why? Both groups on this carbon are same. No. Next, if I have 2-methyl hex 2-ene, 1, 2, 3, 4, 5, 6, 2-methyl hex 2-ene, 2-methyl hex 2-ene. Will this show, students? Yes, no? No. This carbon has both group sames. See, CH3, CH3 present. Will this show? No. Next, 1,1-dimethyl cyclopropane. Both methyl groups are students on same carbon. Last, let's see. If I have cyclohexane, okay, 1, 2 means one methyl group here, one methyl group here. Can they show cis trans? Of course, yes. The structure I have drawn on board is cis. Why? Because both methyl groups are on same site. Even students, it can show transform. See, one methyl group above plane, one methyl group below plane. So correct option is 4, right? Next, so it's from Ionic equilibrium. Very easy question. See, phosphoric acid dissociates in 3 steps. We know n factor is 3. So if dissociation order is this, for first K1, K2, K3, let's start. Log K is this is right. Why, students? You know, when it breaks in step C, H3PO4 giving you what? H plus plus H2PO4 minus. Its dissociation constant is Ka1 first. Then H2PO4 negative giving you what? H plus plus HPO4 2 negative. This is having constant Ka2. Further, HPO4 2 minus giving H plus plus PO4 3 minus. This is what, students? Ka3. If I add 1, 2, and 3, if I add, students, on adding, my final equation looks like this. Confirm this. H3PO4 giving what? 3H plus plus PO4 3 minus. Overall constant be K. Yes. We have done this when we add equilibrium steps. Then equilibrium constants get multiplied. That means K is Ka1 into Ka2 into Ka3. I can take log both sides. So this statement is apt first. Next, this is also right. Why? Students, after loss of one H plus, negative charge comes. Further dissociation and giving more H plus is difficult. So Ka2 would be lesser than Ka1 and Ka3 would be much lesser than Ka2. So this is right. Third is also the same way, statement in different way. Correct? So statement A, B, C are right. D is not correct. It's A, B, C, right. Option 4. Fine. Next, direct question from organic. Soda lime is what? NaOH plus CaO. On putting soda lime, what happens? CO2 out, we get benzene. This is what? Aromatization. From alkanes chapter, we get what? Benzene. This is from alkynes chapter, we get what? Benzene. This we did in phenols also. This we did in amines also. If I put H2O, it's going to produce, students, what? Phenol, not benzene. Rest all will give what? Benzene. If we had put H3PO2, then we would have received what? Benzene. So correct answer is option 4. Fine. Okay, so this is from electrochemistry. Lambda m given, this is of concentration. Okay. Lambda m infinity we can find from this. What's formula for alpha we have done? Alpha is lambda m at any concentration by lambda m infinity. Direct formula. Easy. What's lambda m at any concentration? 90. Lambda m at infinity I'll find by adding these two. 349.6 plus 50.4. So when you solve this, it will be what? 6 plus 4, 10, 10, 10, 400. When we solve this, answer would be around 9 by 40. Answer would be around 0.225. Correct? You can do this calculation. Simple. Fine. Let's proceed. It's again theoretical question. It's from chemical bonding. Let's see. A hypothetical diatomic molecule with bond order 0 is quite stable. Wrong. In MOT we did no. Like if bond order is 0, molecule does not exist. Wrong. Next, as bond order increases, bond length increases. Wrong. Bond order and bond length are, students, inversely related. So both statements are wrong. False. Option 2. Next, it's again from coordination. I think most of students got confused in this question. Students, see, option 1 and 2 don't have ions. So remove them. They are out of picture. They can't conduct. And we know conductance is directly proportional to number of ions in medium, right? This 3 is going to produce 4 ions. How, students? 3 Cl minus 1 coordination compound with 3 plus charge. Last one is going to have 2 ions. How? 1 Cl minus 1 this complex with plus 1 charge. A1 and 2 out of picture. Out of these two, which will have least conductance? Option 4. Right? Next. So we can say it's from P block. We can also say it's from chemical bonding. Just we have to predict structure based on Besseper theory. So students, we know Xe has 8 electrons in valence shell. Correct? 3O. 3O means it's going to make 2 bonds with each O. There is one lone pair. How do we find steric number? Steric number is number of lone pair plus sigma bonds. So it has 1, 2, 3, 4. Steric number is 4. So hybridization is sp3. If I predict its shape with one lone pair, its shape is going to be what? Pyramidal. sp3 pyramidal. Next, students, XeF2. With each F, Xe is going to make what? One single bond. 3 lone pairs are left. What's steric number? 1, 2, 3, 4, 5. 4, 5 means sp3d. sp3d. Let's check its shape. In steric number 5, students, lone pair come at equatorial position. So shape is linear. Hybridization is sp3d. Shape is linear. So let's see B1. Where is B1? 2 places. A2. Okay. We'll have to move ahead. Next is XeOF4. So see, Xe has 8 electrons. With O, it will make double bond. With 4F, it's going to make what? Single bond. So students, what's steric number? 1 lone pair, 1, 2, 3, 4, 5, 6. Steric number is 6. 6 means sp3d2. Yes. So what will be shape? It would be, this is geometry. Lone pair in steric number 6 comes at axial position. So this shape is square pyramidal. sp3d2 with square pyramidal C4. So D also, let's do it. This is best example of what? Distorted octahedron. Because see, it's going to have 6 sigma bonds, 1 lone pair, 7. So steric number is going to be sp3d3 and shape would be distorted octahedral. Option 1. Fine. Next, this is easy question from chemical kinetics. See, delta H is negative. Negative means it's exothermic process. Energy of products should be less than that of reactants. Product should be on lower end. Product lower end, lower end. First and second, fine. These two are already excluded. Students, what is delta H? It is difference in energy of product and reactant. So this is not delta H. This is activation energy. Correct answer is option 1. Fine. This is simple question. I think even in 9th grade we were studying colloids, right? So let's see. Humidity. What's humidity? Water vapor in air. So it is liquid in gas. Students, what's smoke? Smoke is dust particles which are solid in gas. So smoke is solid in gas. Students, alloys. What are alloys? It's homogeneous mixture of metal, non-metal. That means solid in solid. What are amalgam? Amalgams are, students, mixture or solution with mercury. Mercury is solute, which is liquid, with some solid like sodium amalgam. We studied in electro also. So it is what? Liquid in solid. So C4, D3, B2, B2, B, no, sorry, it's A2. So sorry. A2, B1. Option 2. Right? Next, it's from amines chapter. We know basic strength is more if electrons are not delocalized or we have groups which are electron donating. Right? Let's draw structure. What structure of N-methyl aniline? This electrons are in conjugation in ring, but methyl group is donating. What structure of benzenamine? Students, benzenamine is aniline. Electrons are in delocalization. This is right. And methyl aniline would have more than benzenamine because there is additional methyl group donating. Further, ethanamine. What's ethanamine? Students, ethanamine would have basic strength more than these two. Why? Because ethyl group is electron donating plus I. Next, N-ethyl ethanamine. It's 2 degree. I think this should have maximum. So if I draw structure of N-ethyl ethanamine, it's this. So maximum is N-ethyl ethanamine, then N-methyl aniline, then benzenamine. Correct option is option 3. Right? Next, so it's from mole concept, which we are generally scared of, but very easy question. Students, mass is given. First, what I'll do, I'll find moles. How do I find moles? 212 by 106. It's 2 moles. Next, 248 by 62. 4 moles. Whose moles? Whose mass is given? I'll find atoms next. NaOH. If I find moles, 240 by 40. What is this? 6 moles. Next, D is what? Students, 12 by 2, which is 6 moles. Last is what? 220 by 44. So it's 1 by 2, 10 by 2 is 5 moles. So I got what? Moles. But question is about atoms. So see now, one molecule of this has 2 Na plus 1. 2 plus 1, 3. 3 plus 3, 6. 6 atoms. So 6. So 2 moles will have what? How many atoms? 6 twos are 12 atoms. Check next. One molecule has 3 atoms. Or I can say 1 mole of this will have 3 mole atoms. Correct? So this is what moles of atoms. Into 3. 4 threes are again 12. Same number. Next. One molecule or unit has how many? 4 atoms. 6 fours are 24. Different. One has 2. So 6 twos are 12. Next, one has 3. 15. Moles of atoms same. So number of atoms is students in just into Na. Correct? 1 mole of atoms will have Na atoms. No. So we can compare moles. Which numbers are same? These 3. So correct option is A, B, D. A, B, D. 2. Fine. Next. So students, this is direct question based on learning you do in bio also. It's from biomolecules, vitamins part. Vitamin D deficiency rickets. B12 deficiency causes what? Anemia. B2 deficiency causes chillosis. B6 causes convulsions. Let's match. C is 1. C is 1, 2 places. D is D is 2. D is 2. A is 4. Option B. 2. Correct? Next. So this is about acidic strength. We can say it's from carboxylic acid chapter. We can say it's from GOC. So how do we check students' acidic strength? Acidic strength is proportional to stability of negative charge after loss of H plus. So it is directly proportional to presence of electron withdrawing groups. But electron donating groups destabilize anion. So less acidic strength. Correct? Let's check. If I have this, that means C is attached to 3 methyl groups. Here anion is least stable. Why? More plus I effect, correct? Next, here what I have? 2 methyl groups attached. Plus I is still there, but still less. Correct? Here 3. Here 2. Here's there is only 1 plus I because of CH3. Correct? Here there is no plus I. So most acidic should be students formic acid, methanoic acid. This, then this, option 3. Right? Because here 3 methyl groups, more plus I, more donating. Here 2. Here no extra methyl group. Here none. Next. So students, this is from chapter D and F block. Correct. Ferromagnetism is considered extreme form of paramagnetism. Correct. In ferromagnetism, all spin of electrons are oriented in a particular direction. Example of ferromagnetic is like iron, cobalt, right? Next, unpaired electrons in Cr plus 2. Students, what's configuration of Cr plus 2? It is Cr is 3d 5 4s1. Plus 2 means 1 electron from 4s gone, 1 from 3d gone. So it's 3d4. Number of unpaired electrons are 4. Next is Nd. What is Nd? It is from lanthanoid series. LACE, PR, Nd. What's configuration of Nd, students? Nd is xenon, then 4F4 5D0 6S2. Right? We have to talk of Nd plus 3. Plus 3 means, students, 2 electrons from 6s gone, 1 from 4F gone. How many electrons left in 4F? 3. So number of unpaired electrons are 3. This statement is wrong. So what's answer? 1 correct, 1 true, second false. Right? Next, it is from separation techniques. It's from organic analysis, correct? Methods of purification. See, First, how do we distinguish chloroform and aniline? They have very high difference in their boiling points. Like chloroform is around 60 degree, aniline is around 180. So we use what? Simple distillation. A4, A4, 3 and 4 out. Crude oil, I think we know that components of crude oil have very less difference in their boiling point. So we use fractional distillation, B3. Okay. Glycerol. Students, glycerol decomposes when you heat at high temperature. So we heat it under reduced pressure. So C1, direct question. C1 left D2. How do we purify or separate aniline? It's through steam distillation. It's volatile. It goes with steam but not soluble in water. So it's D2. Option is 1. Right. Next. So this is from chemical equilibrium. Reaction rate constant. So see students, K equilibrium or Kc is K forward by K backward. Backward is higher than forward by 2500 factor. That means Kc is 1 by 2500. What we need? We need Kp. What's relation, students? Kp is Kc RT raised to power delta Ng. So what's delta Ng here? 2 minus 1, 1. And delta Ng is 1. Substitute value. 1 by 2500. R given is 0.0831. T is 1000 raised to power 1. When we solve this, 0.0831 into 1000 by 2500. So 25 threes are 75. It should be 0.03 like this. You'll solve this. You can solve. It will be option 3. Next, direct question. It's from amines chapter. Benzene disonium salt is formed by reaction of aniline. We know diazotization. It decomposes easily in dry state. Correct. Why, students? Because N2 is a good leaving group. Just by heating, N2 goes. Right. Insertion of iodine is difficult. Of course. Fluorination also difficult. So we do Bal-Schimann reaction. In order to make iodobenzene, we make disonium salt. Put Ki. Correct. So both statement 1 and 2 are perfect. Okay, so this I think the same question is in NCRT also. Same. We have to find stereoisomers. What's possible, students? Substitution could be here. If I make this product, Cl can come here, right? One product. But once Cl comes here, students, this carbon becomes chiral. 1, 2, 3, and 4th H. Different, no? If a compound has one chiral center, 2 isomers, right? 2 enantiomers. So it will have 2 stereoisomers. Next. What is next possibility, students? Cl can come here. Why not here? Because this and this are same, no? Alike. We'll get same answer only you put here or here. So if I put Cl here, do we have a chiral center? No. So one isomer for this. Next possibility. Next possibility is, students, we can put Cl on this carbon. When we put Cl on this carbon, this is chiral. 1, 2, 3, 4th H. Different, no? So it will also have 2 isomers. Last possibility, we put Cl here. Anything chiral? No. So 1 isomer. Total 2 plus 1 plus 2 plus 1. Answer is option 4, 6. Right. Next is bond dissociation. See, CH bond breaks homolytically. Radical is formed. If you check, students, this chiral carbon is sp2. This carbon is sp. This carbon is sp3. And if it breaks, what we get? We get radical. Homolytic fission, no? Radical here. Here, if this breaks, we get radical on triple bonded carbon. If this breaks, what we get? Radical on sp3 hybridized carbon. If I call the students A, B, and C, what is order of stability? Order of stability is C, A, B. Why? Because radical or positive charge on triple bond carbon is least stable, maximum stable on single bonded carbon. Why? Because of percentage S character. It's sp hybridized, it's sp2, it's sp3. If this is order of stability, that means B is least stable, would have maximum bond dissociation enthalpy, difficult to break. So order of bond dissociation enthalpy is going to be what? 2, 1, and 3. 2, 1, and 3. Option 1. Right? Next, which does not decolorize bromine water? You know, bromine water is a test for unsaturation. There should be pi bonds. 3 gives. Generally, benzene ring does not give. But here, option 2 and 4 both are almost same, right? The only compound where there is no pi bond is 1. So I'm going with options. 1 has none pi bond, right? So option 1. Next, student, this is of Grignard reagent. So see, Grignard reagent will act as nucleophile, causes addition reaction with carbonyl compounds, also with CN. Let's do this. I'm expanding CN and writing like this. In Grignard reagent, students, the part which is attached to Mg carries negative charge. Yes, this acts as nucleophile. This will attack here. Since they have mentioned excess, that means we have unlimited amount, right? This can even attack here. This bond shifts on N. It's not same group. Students, it's in excess. Different molecule or different unit will react. Correct? So when this attacks, what is formed? One more unit. Okay, I'll write one more. This will attack here and this bond shifts on N. What we get? We get CO minus. Methyl group here. 1, 2, C attached to CH3. Double bond N minus MgBr. Next step, we are doing acidification. Acidified water. What is the role of acidified water? O minus will abstract H plus. So final product is going to be option 2. 2 is your answer. Yes. Fine. Next. So students, this is from chapter liquid solutions. What's formula for boiling point? Delta TB is IKBM. And to get boiling point, what we do? Normal boiling point plus delta TB. So I can infer, no, more delta TB, more is boiling point. If you check here, KB is a constant. Yes. So students, delta TB is proportional to what? I into M. I is Van factor. So let's check. If I find I into M, don't have this confusion here. Molarity is given. I into M means I into molality. Sometimes for dilute solutions, we treat molarity and molality same. So let's start. Urea, non-electrolyte. I is 1. 1 into 0.01 is 0.01. KNO3 is made up of K plus NO3 minus. So 2 into 0.01, it's 0.02. Next, Na2SO4 is also electrolyte. It gives you 2 Na plus 1 sulfate ion, which is 3 ions. 3 into 0.01 is 0.03. This is also non-electrolyte, N factor is 1. So which has maximum value, students? It's option 3. Maximum delta TB, maximum boiling point. Next, it's direct question. looking at question, I can understand they have asked catalyst. So Haber's process, Fe catalyst, Waker's process, PdCl2, Wilkinson's catalyst. This is RHCl, PPH3. Ziegler-Natta is this direct match. So it's A1, B2, A, B2, C3, D4. Option 3, direct. So this is again from liquid solutions based on Raoult's law. What they have stated, liquid X 5 moles, liquid Y 10 moles, they are mixed. And it is observed vapor pressure is this much and pure values they have given. So let's first calculate according to Raoult's law. What should be PS value? PS is what? Mole fraction of X, P naught of X plus mole fraction of Y, P naught of Y. Mole fraction is what? Moles by total moles. It's 63 plus 10 by 15 into 78. Answer is in torr. So let's try to solve this. 1 by 3, 3 to the 6, 21 plus it's 2 by 3 into 78. So when I cancel this, 3 ones are 3, 3 twos are 6, 3, 6 are 18. 26 into 2, 6 twos are 12, 4, 52. Answer is what, students? 373 torr. This should be value according to Raoult's law if solution was ideal, no deviation. But answer given is 70. Since 70 is less than 73, that means it is showing what? Negative deviation, simple. Right? Next, sugar. So it's from carbohydrates part of biomolecules. Sugar X is found in honey. Okay, it's a keto sugar. Students, this word keto only tells me it will be what? Fructose. Glucose is aldehyde. Maltose and sucrose both are what? Both are disaccharides. Maltose has only glucose units. Fructose has what? Glucose and fructose unit. But keto part of fructose is bound, no? That's why it's non-reducing sugar. So this keto words tell me it's fructose because it can exist in two forms also, right? And fructose, we know it's levorotatory. So direct question. Next, this is also students direct. It's from chapter aldehydes, ketones, carboxylic acid. It is method of formation of aldehydes. We know when we have any acid or acid derivative, we put dibol H. The only thing they have given now is instead of writing dibol H, they have written formula of dibol H. What's dibol H? Diisobutyl aluminium hydride. Diisobutyl aluminium hydride is this. So dibol H will give you what? Aldehyde. Option 2. Next, this is from haloalkenes, haloarenes. Easy question. What they have said assertion? When I is present, undergoes SN2 faster? Of course, because of bond length factor. Ci is long, breaks easily as compared to CCl. Breaks easily means better leaving group. So see reason also, it's better leaving group because of size. Yes. So both are correct and also reason is correct explanation of assertion. Next, so this is students from thermochemistry. Let's see. Standard heat of formation of Ba+2 is, okay, this is question, we have to find this. What is given? Standard heat of formation of sulfate ion is given. Standard heat of crystallization of BSO4 means crystal to be formed from, according to question, it's formed from ions, right? We'll use them. And standard heat of formation of BSO4 is given. So let's write equation first. What will be equation? Ba+2 ion plus sulfate ion giving you what, students? BaSO4, right? BaSO4. This is equation for the formation of BSO4 crystallization crystal. So students, for this reaction, delta HR is what? Delta H crystallization of BSO4. And whenever for reactants and products, their standard heat of formation is given, we can use this formula, no? Delta HF, heat of formation of products, minus delta HF of reactants. The only thing is they have given standard word. So I'll put not, right? Not, not for standard. What is delta H crystallization? Given is minus 4.5 kilocalorie per mole. Yes. Let's substitute. Okay, I'm removing units. All are same only, no? Units. Left, right. So let's remove units. Let's solve numerically first. This will be equal to, what's product, students? BaSO4. Heat of formation of BaSO4 is minus 349 minus 349 minus, in reactants what we have, students? We have standard heat of formation of Ba plus 2, and for sulfate value is given. What is value for sulfate? It's minus 216. So when I open this bracket, I get what? Take care of calculation, minus minus plus. So therefore delta HF naught of Ba plus 2, which is asked in question, is going to be minus 349 plus 216. This I'm bringing right side, plus 4.5. So it's minus 349 plus 6410 to 20. Final answer has to be negative. These two already out of picture, right? So it's 349.0. Point will come. It's what? 8 minus 0, 8. This is 2 minus 128.5. Obviously, units are same, so it will be in kilocalorie per mole, right? Okay, so this is again from stereoisomers. Let's see. They have said possible isomers of cyclic ether. We have to make cyclic ether only. Formula is of C4H8O. Okay, let's start. First ether possible is, students, see. If I make 5-membered ring with O, does it adhere formula? Cr4, 1, 2, 3, 4, 5, 6, 7, 8. Yes, H also 8. First one. Next is if I make 4-membered ring and put methyl group here. Yes, it's matching formula. Yes. But the thing is, students, this center is chiral. See, this side O, this side chain of CC, this side methyl group 1H. If it's chiral, there will be 2 isomers, right? Next, one more possible, similar kind. When I put methyl group here, is it chiral? No. Why not chiral, students? Because, why not chiral? Because this side carbon O, there is plane of symmetry. It's not chiral. So for this, I will have 1 isomer. Right? Let's move to now 3-membered ring possible. I can make 3-membered ring. I can put ethyl group. 1, 2, 3, 4. 4 carbon. But again, students, this carbon formed is chiral. Chiral means 2 isomers. Now, instead of putting ethyl group, I can put methyl group 1 by 1. Next possibility is C. If I put both methyl groups on same carbon, any chiral center? No. So 1 isomer for this. Next possibility, students, if I put both methyl groups on different carbons. See. Now, as we discussed in one question in today also of stereoisomers, no? The question where it was asked which shows cis trans. Now here see, both methyl groups could be on same site. Yes, this is 1 isomer cis. Because students, geometrical and optical both are stereoisomers. This is cis form. Now I am drawing the trans form. See, 1 carbon has methyl group up. Other carbon has, students, methyl group down, H up. This is 1 more geometrical isomer, but please note it is optically active also. There is no plane of center. Since it is optically active, it will have what? Two isomers, two enantiomers. Correct? Configuration could vary. So total how many? 1 plus 2, 3, 4, 5, 6, 7, 8, 9, 10. Answer is 10. Correct? Next, it's again from inorganic. Dipole moment. H2, obviously, O is more polar, no? Dipole moment is mu into D. So H2 has more dipole moment than NH3, correct? It's around 1.8. This is around 1.6 something, right? Not to learn, but these are values. Then NH3. This order is right. Next is number of lone pair. 4 bonds made, 5, 6, 7, 8. It will have how many lone pair students? 2. Here, 6 electrons used in making 6 bonds with 3 O. So how many lone pair? 1. Here, how many lone pair? 2 sigma bonds done, right? Then 2, 3, 4, 5, 6, 7, 8. It has 3 lone pair. Is this order apt? No. Bond length, OH. Students, O is smaller in size than C and N. H is also. So this order is absolutely wrong. OH bond is shorter than NO and CH. Next, bond enthalpy. This seems right. Why, students? Because N exists in triple bond. O exists as double bond O. H as single bond. So bond strength, what is BS? Bond strength. It's directly proportional to bond order. N2 we claim to be inert also because of very high bond enthalpy. So correct answer is option A and D only. Right. Next, so this is from Lee Chatillon's principle of chemical equilibrium. They have said it is endothermic. Endothermic means I can put heat sign here, right? Now question is, how will I get higher yield of NO? Obviously, for endothermic, if I increase temperature, equilibrium shifts in forward direction. So high temperature is one option. Plus, if I increase yield of N2 and O2, it shifts in forward. So higher concentration of N2 and O2. Answer is option A, C, D. B, no. Low temperature will bring it backward. So it's A, C, and D only. Right. Next. So this is of chapter chemical kinetics. What is given? Rate constant. This is K, right? This is initial concentration. This is concentration left at time t. Right? Now see, rate constant has these units. You know the how to get order of reaction. Then only will apply formula. In rate constant units, whatever is the power of L, liter, you add 1 to it. That gives you order. Here L is 0, right? If I add 1 to it, what is order of reaction? 1. So I'll go with the equation, integrated rate equation of first order kinetics. What formula I'll use? T is equal to 2.303 by K, log of initial concentration by concentration left at time. Let's substitute values. What's K? 0.03. Initial is, left is, so 9 8s are 72. Log 8, students, I can write as log of 2 cube. Bring 3 in front. Log 2 value they have given 0.3. Correct? So 0.01. Log 2 is 0.3. 3 ahead. If we solve this further, answer is going to be 2.303 into 3. Then we'll just shift decimals. 3 3s are 9, 0, 9, 3 2s are 6. Yeah. Into 10 raised to power 3 here plus 1 minus 4 plus 2. So it's 6909 into 10 raised to power minus 2, which is around 69.09 seconds. Correct? So correct answer is option 1. Fine, students? Yeah. Okay. Next, moving on to last question of our discussion. It's easy question. It's again from organic analysis. Lazine test. Students, Lazine test is used for detection of halides, nitrogen and sulfur, not for carbon. This is Liebig's method. So which is not apt? Fourth one. Rest halide, sulfur, nitrogen. Correct. So our discussion is over. Paper was moderate. I hope you get good score and all the best for your results, students. Right? That's it. Okay. Take care. Thank you.